we compare the means of the sample that we have with the mean of the population. The example of case or case of example in the one sample test is like this. My teacher will conduct research on students in one of the classes he teaches. He wants to know whether the average meta score of students in the class have reached the school's minimum passing grade of 80. To do this, he collects test score data from 30 class as follows. So we have one data student in the class with the different math score. To do this research, we will use the statistical test is one sample t-test. It's because we just compare one sample with a value. One sample in this, it is the sample in the table, get the math score in one class. And the value is the school's minimum passing grade. It is the 80 in this case. So we have one sample in one class and one value in school's minimum passing grade. So we use one sample test. But before we conduct research about one sample test, we must check the normality of the data with normality test. It's because it is the condition that must be true before we do the test of one sample test. To get the normality, we use the hypothesis. It is the null hypothesis is H0. Let's say the sample comes from a normally distributed population and the H1 as the alternative hypothesis. Let's say the sample does not come from a normally distributed population. Then the test criteria that used is level of significance 5%. If significant value that we get from the calculation is greater than 0.05 or 5%, then we accept H0, which means that the sample comes from a normally distributed population. But if significant value is less than 0.05, we will reject H0 and accept H1, which means that the sample does come from a normally distributed population. For a statistical calculation, we use SPSS to get the output of normality test. So we can copy first data in our sample. Copy, then we go to the SPSS. Yeah, I have input the data in the SPSS, change the name with X, that mean variable of X. The decimal is 0 because no decimal value in our data. Change the label into math score. And the measure is scale because the data is data scale. Then to get the normality test, we go to analyze, descriptive statistic, and explore. Input the math score to the dependency list, go to the statistic, yeah, plot it like that. Go to the plot and check the normality plot with test, click continue. After that, we can just click OK, and you will get the result like this. We have some table with so many data, so many number, but don't be confused. We will just focus on the one table. It is test of normality. We have the table of test of normality. We have two types. This is the first is Kolmogorov-Smirnov and the second is Sapir-Whorf. Because our data is just 30, it's a small data because not reach the 50 data. So we use the Sapir-Whorf. If we have the large data like greater than 50, we can use the Kolmogorov-Smirnov. Based on the test of normality table, the significant value in Sapir-Whorf show that the significant is between that the sample comes from a normally distributed population. So the conclusion that we get is the sample is normally distributed because it's normal. So we can go to the comparative test. It is the one sample test. Same is have a research hypothesis. The hypothesis first is H0. The mu equal 80 means that the average math test score of student in the class is 80, and the H1 is the mu not equal 80 means that the average math test score of students in the class is not 80. Test criteria, we use two tail tests with level of significance 5%. If the significant value that we get is greater than 0.05, we accept H0, which means that the average math test score of student in the class is 80, so we accept this. But if the significant value is less than 0.05, then we reject H0 and accept H1, which means the average math test score of student in the class is not 80. The statistical calculation, same, we use the SPSS, sorry, but it's not normality from the one sample. On SPSS, but in this step, we use the compare means and one sample test. Click, input the math score data into test variable, and change the test value into the our value compare. In this case, we have the value is 80, so we use test value 80. Click OK to table, scroll down. We get two table in the test. First is one sample statistic, and second is one sample test. First, we focus on one sample test table. The output from the sample one sample test is we reject H0 and accept H1, which means that the average math test score of student in class is not 80. In the conclusion, we get that the average math test score of student in the class is not 80. But if we only stop in this conclusion, it's not answering the question of the research that conduct in the first. If only the conclusion is not 80, it's have two possibility. Maybe it's less than 80, that means not reach. Maybe also it's greater than 80, that means that reach the school minimum criteria. So we not end in this step. Then we back to the result of SPSS. Then we can focus on the other table. It is one sample statistic. So we can see on the statistic table below. Before we get the average match of the test score student is not 80, and in other table, in one sample statistic table, we get the mean is precisely in 75.50. So we can get the next conclusion that the mean of the sample is only 75.50, and that means it's not reach the school minimum of criteria 80. So it is the simulation of research about the case with one sample t-test. You can see the step by step and how to use SPSS, how to conduct the hypothesis, the normality test, and until get the conclusion about the comparative test.
Okay, next is sample t-test. Sample t-test is used to compare two means of two groups. So next, there is the requirement to use sample t-test. First, dependent variable that is continuous. Second, relate sample or group. And the third is random sample data from population. And the last is normality distribution. So the data is mass normality distribution. So we have a researcher want to know the effect of the comparative learning type jigsaw learning model on math learning achievement. From one class, only 10 students were sampled, and an achievement test was conducted before and after the comparative learning type jigsaw learning model was applied. So this is the data before applied of jigsaw learning models, and this is after applied. Next, from with a significant level of alpha is equal to 0.05, is there an effect of cooperative learning type jigsaw learning model on math learning achievement? So to before we start to parse sample test, we must make a hypothesis. First hypothesis or hypothesis 0, if both population means are the same. So it means that there is no effect of cooperative learning type jigsaw learning model on math learning achievement because they have a same means. Okay, and the next is hypothesis 1, where the past population means are not same. So it means that there is an effect of cooperative learning type jigsaw learning model on math learning achievement. So next is statistic criteria. After accept hypothesis 0 if the value of significance is greater than alpha equal to 0.05. Okay, next we will move to statistic. Okay, so we have this is the data that we have from the problem. X1 and X2 is X1 for before and X2 is for after applied of jigsaw model. So we change on variable field decimal, we change into 0, and for the name X1 is for before and X2 for after. Next we because in the previous before I said that the requirement for the data is not normal distribution. For this problem, the data is normal distribution, so we will next to parasympathetic test to find the effective. Okay, first is analyze and companion parasympathetic test. Okay, we put x1 into variable 1 and x2 to variable 2, and we click option. So we must to make sure that confidence interval percentage is 95% because because on the problem it said that the alpha is equal to 0.05. So we click continuous and okay. So we have three tables. So first, if we look at the first table, we can see that the mean of two group is different, right? So the first for before we applied is 73.80, and for after we applied jigsaw model, we got means is 79.60. So and then from this is we can to conclude that there is an effect of use jigsaw model on mathematics achievement, but because this is for sample data, so we see for this table, we got the significant is 0.02. So from the um, criteria, they said that hypothesis zero is accepted if significant value is greater than 0.05. But because for this problem, the significant value is 0.002, so hypothesis 0 is rejected, but we accepted the hypothesis 1. So it means there is an effect of use jigsaw model cooperative learning on mathematics assessment. So next we'll present by my friend from the description or how to make analysis of this table.
Hello everyone, I will explain about the per sample test output. After conduction the per sample test in SPSS, we obtain several output table. Now, I will explain as important part of the result so that we can draw the correct conclusion. They are the main table we need to review. And first is descriptive statistic table and per sample correlation table and per sample test table. The first table is descriptive statistic. Here we can see the mean and the number of participants or n, standard deviation, and standard error mean for the score before and after treatment. The result or mean before treatment is 73.8 and mean after treatment is 79.6 and participant is 10 student and standard deviation before approximately is 4.662 and before approximately is 2.5503. And standard error mean is x1 is 1.474 and x2 is 0.792. Looking at the descriptive statistic, it is clear that there are different between x1 and x2, where after the application of the learning model learning achievement recess. This show that there is increase in student reference score after the application of the cooperative learning jigsaw model. However, even though the mean has increased, we cannot directly conclude it is statistically significant yet. We still need to check the t-test result. And then next, we look the correlation table. We saw the relationship or association between the score before and after treatment. The results are correlation coefficient is 0.402 and significance is 0.250. A correlation is 0.4402 indicated a low to moderate positive relation since the significance value is 0 0.25 50. And the next per sample test. Let's break it down mean different is after and before is mean for 5.8 and standard deviation is 4.315 and standard error mean is 1.365. And the value is mean 4.250 and decrease of freedom or DF is 9 because 10 minus 1 is 9 and significance is 0.002. HO is rejected and accept HA because significance is 0.002 kurang dari 0.05, meaning that the average difference is different, so it can be said that the application of the cooperation learning teaching learning model is effective on math learning edges. We also can check by t-table. By per sample test table, we can degree of freedom is 9 from n minus 1. 10 minus 1 is 9. And we have a alpha is 0.05, then 0, 0.025 is t-testable. So, therefore, since the value of the cone is 4.250 kurang dari t-table 2.262, the HO is rejected and accept HA. So, conclusion is based on the result of the per sample test, we can state we confident that the cooperative link jigsaw model effective improved the student mathematics assessment statistics analysis confirmed that this improvement did not occur by random checks. Therefore, we can confidently say that active and cooperative link strategies such as the jigsaw model play crucial role in enhancing academic performance and should be considered as valuable tool in education process. And thank you.
Next is independent sample t-test. So guys, independent sample t-test is used to determine there is a significant difference between two groups in particular variable. So in independent sample t-test, there is several assumptions or conditions that should be fulfilled before we analyze. The first one is independent data. So here, independent sample t-test, the data that we want to analyze should be independent. And the second one is the data should be normally distributed. And the last one is the data should be homogeneous. This is the variance of the data should be same or equal closely to the same. Guys, to make sure our understanding about independent sample test, here I have a problem. The problem is, researchers want to find is there any significant difference between student score in experiment class and in a control class. So here, I open the SPSS and I have input the data, student scores data, from experiment class and control class in a data view, and we can name it in the variable view. Here, experiment and control, and if the decimal is still 2, we can change it to 0. Okay, if we want to analyze this independent sample t-test, we should fulfill the assumption first, right? The first one that I said before is independent data. This is obviously an independent data, right? Because data from experiment class and control class is different. Okay, the second one is normally distributed. So we can do the normality test. The step is we click analyze and then descriptive statistic and then explore. And then we can input the experiment and control data to the dependent list and we click plots and then we click this none and we check for normality plot with test and we check for stem and leaf and then we click continue and then we click OK. So the SPSS will working and we get this output is test of normality table. Here we can see from the Kolmogorov Smirnov there is significant value from experiment class and on control class that is 0.200 for both class. So it means the data is normally distributed. So we can move to the next step, that is homogeneity test, the third assumption, right? For the step, firstly, we should make one column again. Here we copy the data from experiment class and we paste it to the third column here. And we do the same for the data in the control class. We copy and we paste it in the below of the experiment data. Okay, so we click variable view and we can name it as experiment control. Okay, so we can change the decimal into 0 and then we go back to the data view and here I will define the experiment class as 1. I classified. So the data from experiment is 20, so we can change 1 until 20 data as 1 and for the rest is 21 until 30 is 2. It means the control data. Okay, like this. So we have 1 and 2 in here. So move to variable view and then we can change the name is maybe class and then we change the decimal and then we click at the value here and then we add 1 for experiment and then we add it and then number 2 is for control and then we add and we okay, so we back to the data view here and we can see it's classified from data experiment and data control class. So we can now analyze descriptive statistic and then explore and then here we move the experiment and control data before and we move experiment control, the new column, to the dependent list and then for the data class in the factor list and then we click plots and then we uncheck from stem and leaf also the normality plot with test we uncheck it and we click power estimation and we click continue and then OK. So the SPSS will working again, and we get the output is test of homogeneity of variance table. And here we can look at the based on mean. We have the significant value is 0.850. It's mean the data is homogeneous. Okay, so we have fulfilled the assumption, all the assumption, okay, for normality and homogeneity. So we can analyze for independent sample test. The step is click analyze and then compare means and then independent sample test. Here we move the experiment control to the test variable and class to the grouping variable. And we click define groups, and group 1 we add 1 and group 2 we get 2. And we click continue and then we click OK. And the SPSS will working again. And the output is we have group statistic table and independent sample test table. And here we can see the mean from experiment and control class. There is a significant difference, right? 81.25 and then 66.54. And then independent sample test table here, we see at equal variance assumed since the data is homogeneous. And then we can see from the T table and F, and also the significant value in here is 0.001. It means there is a significant difference between data and experiment and control class. Okay, so maybe that's all about step by step how to use independent sample data by SPSS, and for the further explanation will be discussed after this.
Hi everyone. So, we are going to discuss about the analysis of the independent sample test. So, before that, we already have the table from the application of the SPSS before. So, eventually, in this independent sample test, we have three. We have three main analyses in here. We have the normality test, firstly, and then we have homogeneity test, and also for the last is independent sample test. Why? Because we need to make sure that the data is distributed normally, and also they are homogeneous, where they are the same. There's no difference between them. So yeah, first normality test, where the hypothesis of the normality test are H0 is the dependent variable is normally distributed, and H1 is the dependent variable is not normally distributed. Okay, for the statistical criteria, we will accept the H0 if the value of significance are greater and or equal than alpha, where the alpha value is equals to 0.05 or 5%. Okay, we have the statistic results in here by SPSS, the test of normality. Then we can see the significant value in here. We have that the significant value are 0.200, both of them. So by that we can say the conclusion, since both of experiment class and control class have significance is equal to 0.200 is greater than 0.05, the alpha value, so H0 is accepted. Thus, it means that both of the experiment class and control class are normally distributed. So the second test is homogeneity test, where we said that the hypothesis for H0 is sigma 1 square is equal to sigma 2 square, or which means the variance are the same, both are homogeneous. And for the H1 is sigma 1 square is not equal to sigma 2 square, where the variance are different and both are not homogeneous. I mean, both of the data are not homogeneous. So the statistic criterion here in homogeneity test is accepted H is null if the value of significance are greater than alpha is equal to 0.05. In here we have the statistic results by SPSS of the test homogeneity of variance. We would like to see in here the significant value of based on mean. We have that the significant value is 0.850. For the conclusion that since the significant value is 0.850, it is greater than the alpha value where it is 0.05, so it's null is accepted. It means that there are no difference between the variance of class experiments data and class control data, which means they are homogeneous. Okay. The last test will be the independent sample test, which the hypotheses are H0 is mu1 is equal to mu2. That means the mean of samples are not different, and for hypothesis 1 or H1 is mu1 is not equal to mu2, where the mean of sample are any different. Okay, the statistic criteria will be accepting it's null if the value of p-value is greater or equals to 0.05. By that, the statistic results from SPSS, we have the group statistics in here, the table of group statistics, and also the table of independent sample tests. Okay, in the first table, we have the group statistic. We would like to see in here the mean of class experiment and also class control. We can see that the class experiment have the mean is 81.25, and the class control we have the mean is 66.54. It means that there are difference between the means of the experiment class data and control class data, right? And also, for the independent sample test table, we would like to see the t-value in here, the t-value of the equal variance assumed. Why we use the equal variance assumed? That's because we already do the homogeneity test, and we can see that both are homogeneous, they are the same. Okay, we have the equal variance assumed the t-value are 3.342 where it is greater than 0.05. And by that, the conclusions, by resolving the H1, then the average of the two groups are different. We can see at the output group statistics, apparently the average of experiment class 81.25 is greater than the average of control class, which is 66.54. Thus, the experiment class has a better average of improvement of learning achievement than the average of control class. We can conclude that the new learning strategies are able to improve a student's learning achievement. Yeah, that's how we analyze the independent sample t-test.